Hi students, welcome to Sunil's tutorial. I am Sunil Mirwani and today we will be doing this chapter of chemistry called as alkanes. Now, what are alkanes? Definition. How do I define alkanes? Alkanes are nothing but they are saturated aliphatic hydrocarbons. They are saturated aliphatic hydrocarbons. Right? Meaning, what do you mean by each of this word? Saturated. Saturated means the carbon valency is satisfied by a single bond. There is a single bond between carbon-carbon. Aliphatic means they are straight chain compound. Hydrocarbons means besides carbon they also have hydrogen in it. Right? They are saturated. Saturated means carbon-carbon valency is going to be 1. The valency between two carbon atoms is going to be satisfied by a single bond. Aliphatic means straight chain compounds, right? And hydrocarbons means besides carbon they also have hydrogen in them, right? Now, they are also called as paraffins. Some authors even call them as paraffins. Alkanes are also called as paraffins, also called as paraffins. Why are they called as paraffins? Because they have low chemical reactivity. Para means low, affins means affinity. The word paraffin means low affinity. The literal translation of the word paraffins is low affinity. Why are they called as paraffins? Because they have low chemical reactivity. Right? Now, they have general formula CnH2n plus 2. That is the general formula. Fine, do we get this in here? Now let us see. So this is your definition of alkanes. What are alkanes? Alkanes are saturated aliphatic hydrocarbons which are also called as paraffins because of their low chemical reactivity, having general formula CnH2n plus 2. Right? Break it up, it's easier to learn. Now, let's see what are the different types of alkanes and their names. Names and molecular formulas. Guys, this one part that I'm going to teach you, if you want to be very good at chemistry, this one paragraph that I'm going to teach you, you should know this. I learned my entire chemistry with this paragraph. Till today I don't know chemistry, but I know this paragraph very well. Once you know this particular paragraph, you can solve anything in chemistry. It's like your formulas you have in maths. It's exactly a replica of that, right? Now, number of carbon atoms. N stands for number of carbon atoms. Right? So, N, name and molecular formula. If you have one carbon atom, any organic compound, you have to know how to read carbon atoms. All you should know in organic chemistry is how to read carbon atoms. If you have one carbon atom, then the name is going to be methane, METH. So whenever you see one carbon atom, it is METH, right? C, one carbon atom, right? Now, if it is C, what is the valency of carbon? Valency of carbon you are supposed to know by heart is 4. Guys, see this. Valency of carbon is 4. That means how many hydrogens do I require to satisfy this valency? So then the formula should be CH4. Right? Simple. Suppose if I have two carbon atoms, guys, if I have two carbon atoms, then the name should be ethane. Okay? Two carbon atoms. These are aliphatic hydrocarbon. That means carbon-carbon valency is going to be 1. We know that valency of carbon is 4, out of which one bond is satisfied here. How many bonds are free? 3. Valency of carbon, guys, is 4, out of which 1 is satisfied here. How many bonds are free? 3. So how many hydrogens should be there? 3. On this side also 3. So molecular formula is H3C bond, single bond CH3. Fine. Next, if you have 3 carbon atoms, then that is called as pro. Right? And since this is alkane, this is propane. 3 carbon atoms. C, C, C. This carbon atom has only one bond. This carbon atom has only one bond. That means how many hydrogen atoms should it have? 3, because valency of carbon is 4. This carbon atom has 2 bonds. One bond here and one bond here. That means how many hydrogen atoms should it have? 2, because valency of carbon is 4. How do you know the number of hydrogen atoms? The number of hydrogen atom is 4 minus the number of bonds. 4 minus 2 bonds, so H2. How many bonds does this carbon atom has? 1. So how many hydrogen does it have? 3. So propane is CH3, CH2, CH3. That's how you write the molecular formula. Right? Next, if you have 4 carbon atoms, then that name is called as butane. Right? Butane. 1, 2, 3, 4. 4 carbon atoms. Bond, bond, bond. Right? Learn the method to write it. There are a lot of people who try to mug up chemistry. You cannot mug up formulas. If you know your method, then it is very easy. This has one bond, that means this will be CH3. This has 2 bonds, that means this will be CH2. Because 4 minus 2. 2 bonds, CH2. 1 bond, CH3. CH3, CH2, CH2, CH3. Butane. Right? 5 carbon atoms is pentane. Right? Now, I will not show you the structural formula now. I will show you the molecular formula. 5 carbon atoms. What is the general formula of alkane? CnH2n plus 2. Right? That means how many hydrogen atoms should be there? N is 5. 5 2s are 10. 10 plus 1, 11. So this will be C5H11. Fine, do you get this thing here?
So
H2n, sorry. Plus 2. I'm sorry. I said I did alkyl blue. Right? Instead of alkane blue. So CnH2n plus 2. So this is going to be C5H12. Fine, do we get this thing here? 6 carbon atoms. What is 6 carbon atoms? 6 carbon atoms is hexane. Hexane. 6 carbon atoms. CnH2n plus 2. 6 2s are 12 plus 2, 14. So C6H14. 7 carbon atoms. 7 carbon atoms is going to be heftane. Right? Heptane. 7 carbon atoms. 7 2s are 14 plus 2, 16. 8 carbon atoms. 8 carbon atoms is octane. 8 2s are 16 plus 2, 20. 9 carbon atoms. 9 carbon atoms is nonane.
So the number of carbon atoms will be given in the paper?
No, I'll show you how we use this. First, just understand this.
It should be 18 now.
8 to the 16, yes, 18. Right? Next, nonane, 9 carbon atoms. Right? 9 2s are 18 plus 2, 20. H20. 10 carbon atoms is decane. Right? 10 2s are 20 plus 2, 22. C10, H22. So those are the names and molecular formulas. Right? Next, structural formula. What do you mean by the word structural formula? Right? The formula that gives you the exact arrangement of atoms of different elements, then that is called a structural formula. Here, what did I show you? This is structural formula. It tells you exactly how the carbon atoms are arranged, how the hydrogen atoms are arranged, how many hydrogen atoms is attached to every carbon atom. So that structure is called as structural formula. So what is structural formula? Please write this down. Structural formula gives exact arrangement of atoms of different elements present in a molecule. That is what is structural formula. Fine. Now, once you know what is structural formula, let us try to understand the structural formula of methane in detail. Let's see the structural formula of methane. Now, methane is the most simplest of alkane that you can have. Right? It is made up of, its molecular formula is CH4. Its molecular formula is CH4. It is made up of single carbon atom and 4 hydrogen atoms. Fine? When you are doing structural formula, the bonding is represented with the help of a single bond. If you are doing dash structure, I'll show you that there are two ways of writing a compound. One is called as the dash structure, the other is called as the dot structure. Fine? Do we get this? See, structural formula, carbon. The covalent bond between carbon and hydrogen is shown with the help of a single bond, where one electron is given by carbon, one electron is given by hydrogen. Same way here, hydrogen, hydrogen, hydrogen. This is called as the dash structure. Right? Instead of showing the bond with the help of a line, you can also show the electrons. Right? Where see, carbon, guys, has 4 electrons in its outermost orbit. I'm showing the electrons with the help of cross. Each of this will form a covalent bond with hydrogen. Hydrogen will give 1 electron, which I'm showing with the help of a dot. Right? This is called as the dot structure. Here the covalent bond, see this. Now you will have 8 electrons in the outermost orbit of carbon and 2 electrons in the outermost orbit of hydrogen. Thus, the valency of carbon as well as hydrogen is satisfied. Fine, do we get this thing here? If this is your structural formula of methane, I can show you the structural formula of ethane also.
So can I explain the dot structure?
Sure. I'll show you the dot structure again. See, carbon. Carbon has 4 electrons in its outermost orbit. 1, 2, 3, 4.
We have to peculiar way of doing no.
Any just cross, simple cross. Put the cross anywhere, right? This is going to combine with 4 hydrogen. Hydrogen has 1 electron in its outermost orbit. So here one covalent bond is formed. Hydrogen has 1 electron in its outermost orbit. So here one covalent bond is formed. Hydrogen has 1 electron in its outermost orbit. Here one covalent bond is formed. Hydrogen has 1 electron in its outermost orbit. Here one covalent bond is formed. Now if you look at the outermost orbit of carbon, it has 8 electrons in it. 4 of its own and 4 which it is sharing with hydrogen. So it is in octet state. And if you look at hydrogen, each hydrogen has got 2 electrons in its outermost orbit. One its own and one which it is sharing with carbon. Right? This is called as dot structure. Generally in chemistry, we always use the dash structure. We rarely use the dot structure in chemical equations. Right? Next, let's see ethane. Guys, ethane, E means 2 carbon atoms. Ethane, that means it is an alkane. It will have general formula CnH2n plus 2. So 2 to the 4 plus 2 6. It's 6. Let us see the dash structure. It has 2 carbon atoms. Valency of carbon is 4. Valency of carbon is 4. Each of the other bond is connected with hydrogen. This is going to be the dash structure of ethane. This is how ethane looks like. This is the dash structure of ethane. Right? Now dot structure. Guys, see this, carbon carbon. They are going to have similar electrons, right? So you are going to have one electron here, one electron here. Carbon has 4 electrons in its outermost orbit. First I'll show you for one. 1, 2, 3, 4. This carbon has 4 electrons, right? This carbon also will have 4 electrons. 1, 2, 3, 4. Both the carbons have 4 electrons. This will react with hydrogen with one bond, hydrogen with one bond, hydrogen with one bond. This will react with hydrogen with one bond, hydrogen with one bond, hydrogen with one bond. This is how ethane will look like in the dot structure. This is the dot structure of ethane. Fine, do we get this in here? Similarly, I can have for propane. Propane. 3 carbon atoms. Prop means 3 carbon atoms. Right? ANE, alkane. That means its general formula will be CnH2n plus 2. 3 2s are 6 plus 2, 8. Right? Now, 3 carbon atoms. There's a bond between them. Each carbon has a valency of 4, valency of 4, valency of 4. The bonds are connected, the remaining bonds are connected to hydrogen atoms. This is your structure of propane, right? This is your dash structure of propane. Carbon, carbon, carbon. Now see this, guys, let's see the dot structure. Valency is 4. 1, 2, 3, 4. This carbon atom has 4 electrons, right? Let's bring this carbon atom close. 4. 1, 2, 3, 4. The next carbon atom also has 4 electrons. 1, 2, 3, 4. Fine. Now, hydrogen with 1 electron. Hydrogen with 1 electron, hydrogen with 1 electron. You have hydrogen with 1 electron, hydrogen with 1 electron, hydrogen with 1 electron, hydrogen with 1 electron, and hydrogen with 1 electron. This is going to be your dot structure, right? This is your dot structure of propane, right? Next, let's see for butane. Butane, right? It has 4 carbon atoms. 4 carbon atoms, that means it will have CnH2n plus 2. 4 2s are 8, 8 plus 2, 10. H10, right? Now, let's see this. 1, 2, 3, 4. 4 carbon atoms. Draw your remaining bonds. Right? Each of the remaining bond is going to be connected to hydrogen. Right? This is your C4H10. This is your dash structure. Right? Next, let's try to see the dot structure for butane. 4 carbon atoms, guys. Take one carbon atom at a time. This carbon atom has 4 electrons, right? Next carbon atom has 4 electrons, 1, 2, 3, 4. Next carbon atom has 4 electrons, 1, 2, 3, 4. Next carbon atom has 4 electrons, 1, 2, 3, 4. Right? So I have drawn all the 4 carbon atoms with their electrons. Now put in your hydrogen. Hydrogen with a dot, hydrogen with a dot, hydrogen with a dot, hydrogen with a dot, hydrogen with a dot. All you have to remember is that when you're drawing the bond with hydrogen, you're going to put your dots. So this is going to be your dot structure of butane. Fine. So this was structural formula. This is how they look structurally, right? Next, let us classify alkanes. Let's see classification of alkanes. Now when we talk about classification of alkanes, alkanes can be classified as straight chain alkanes and branched alkanes. Alkanes can be classified into straight chain and branched. That's your basic classification of alkanes. Right? Now, what do we understand by straight chain alkanes? These are alkanes in which the carbon atoms are in a straight continuous chain, right? Carbon atoms are in a straight continuous chain, right? Carbon atoms, this is your carbon atoms, okay? Or so this is your straight chain carbon atoms, right? For example, if I draw butane, example, butane, 4 carbon atoms, guys, 1, 2, 3, 4, butane, bu means 4 carbon atoms, right? Straight chain, this carbon atom has 1 bond, so H3, right? This carbon atom has 2 bonds, H2, 2 bonds, H2, H3. All the carbon atoms are in a straight line. This is straight chain. This is butane. In order to indicate that they are straight chain compounds, some authors even call this as N-butane. N-butane to indicate normal butane. N, the word N indicates normal. Normal indicates straight chain compounds. Fine, do we get this in here? Similarly, you can have, say, pentane. 5 carbon atoms, 1, 2, 3, 4, 5, right? 1 bond, so H3, 2 bonds, H2, 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 H3. All of them in a straight line. This is pentane. This is straight chain, therefore this is called as N-pentane. Fine, do we get this thing here? Now, so that is your straight chain compounds, right? Now when we talk about branched compounds, when we talk about branched alkanes are further classified into 2 types. They are further classified into 2 different types of structure. One is called as the iso and the other is called as the neo structure. You have iso structure and you have neo structure, right? What do we understand by iso structure? Iso structure, when the branch contains an alkyl group in the second carbon atom, then that is called as an isostructure. See, guys, look at this. Count from any direction. Let's look at butane. 1, 2, 3, 4. Or you count from here. 1, 2, 3, 4. Either. Now, if I consider this as first carbon atom, this is my second carbon atom. On the second carbon atom, if I have a branch and if that branch contains an alkyl group, what is the alkyl group? CH3. Then that is called as an isostructure, right? So isostructure, I'll show you the example first. Let me write the definition. Isostructure, these are alkanes which contain one carbon branch When I say carbon branch, what do I mean? I mean CH3. That's your alkyl group. One carbon branch attached to the second carbon atom of a normal chain. Attached to second carbon atom of normal chain. right? These are called as isostructures. For example, now suppose if I want to make isopentane, 5 carbon atoms, 1, 2, 3, 4. Second carbon atom, put a branch where you will put C. This is isostructure. To the second carbon atom, you will put CH3. That is what I meant when I said this. Which contain one carbon branch. This is the carbon branch attached to the second carbon atom. I have a carbon branch attached to the second carbon atom. This is called as isostructure. Right? Now let's see the hydrogen. This carbon atom has one bond, so H3. This carbon atom has two bonds, therefore H2. This carbon atom has three bonds, therefore H. And this carbon atom has one bond, therefore H3. This also has 5 carbon atoms, but I have the methyl group in a branch, or I have a carbon atom which is in a branch and it is connected to the second carbon atom. Then that is called as isopentane. We get this in here? Now, what do you understand by neostructure? In isostructure, you had one carbon branch. Instead of one carbon branch, if I have two carbon branches attached to the second carbon atom, then that is called as neostructure. These are bonds which contain two carbon branch attached to second carbon atom, instead of having carbon atom of a normal chain. Right? Instead of having one branch, if I have two branches, then that is called as neostructure. Fine, do we get this in clear? For example, let's do pentane again. Pentane, 5 carbon atoms, carbon, carbon, carbon. I've written 3. This is the first carbon atom, second carbon atom, third carbon atom. Question, sir, why is that the first carbon atom? Why is this not the first carbon atom? Take this as the first carbon atom. Doesn't make a difference. First carbon atom, second carbon atom, third carbon atom. To the second carbon atom, if I have two branches attached, one branch here, one branch here. To the second carbon atom, if I have two branches attached, and in both the branches if I have a CH3 function, if I have a methyl group, then this kind of a structure would be called as a neostructure. Now let's look at this carbon atom. This has only one bond, so this is CH3. This has all the 4 valencies satisfied, so this will not take a hydrogen. This carbon has one bond, therefore CH3. Right? So in that case, this is going to be neopentane. It has 5 carbon atoms, but it has 2 branches on the second carbon atom, therefore this will be called as neopentane. Fine, do we get this thing here? So do we understand the classification of alkanes? Next, let's see isomerism. Now, I just taught you 3 compounds. Guys, let's see the 3 compounds I taught you. One was pentane. Pentane. It had 5 carbon atoms. Guys, look at this. How many hydrogen atoms here? It had 3, 5, 7, 9, 12. It had 12 carbon atoms. It had 5 carbon atoms and it had 12 hydrogen atoms. Right? Let's see isopentane. Isopentane also has 1, 2, 3, 4, 5 carbon atoms. Hydrogen atoms 3, 5, 6, 7, 8, 9 and another 3, 12. It has 12 hydrogen atoms. N-pentane has 5 carbon atoms and 12 hydrogen atoms. Isopentane has 5 carbon atoms and 12 hydrogen atoms. Let's look at neostructure, guys. 1, 2, 3, 4, 5. neopentane also has 5 carbon atoms. How many hydrogen atoms it has? 3, 6, 9, 12. It again has 12 hydrogen atoms. That means all of them have the same molecular formula. So in that case, what is different in them? Their structural formula is different. All of them have different structural formula. So compounds which have same molecular formula but have different structural formula are called as isomers of each other. So N-pentane, isopentane and neopentane are isomers of each other. Fine, do you get this thing clear? Do we understand what is isomerism? It is a property wherein a compound exhibits same molecular formula but different structural formula. It exhibits same molecular formula but different structural formula. Fine, we get this thing clear? So these are isomers. I'll just write this down. What is isomerism? These are compounds having same molecular formula right, but different structural formula. Compounds having same molecular formula and different structural formulas are called isomers, and the property is called isomerism. Right? Do we understand what is isomerism? So isomerism is a property wherein you have same molecular formula but different structural formula. Right? Do we understand this? Okay, we'll stop this here for the day. Thank you very much.